To confirm an optimal watercourse crossing location and create an effective crossing structure design, it's important to understand the local features and processes within the natural watercourse and the potential watercourse crossing site. This is done by conducting a detailed site assessment and survey. Site assessments and surveys gather critical information on habitat features and the geomorphology, or surface features, of the watercourse and surrounding area. The site assessment process starts in the office with desktop tools, such as maps, aerial photos, Google Earth, and LiDAR. These desktop tools can help identify landscape and habitat features that could influence crossing designs, such as upstream barriers, debris, or historic beaver activity. Gathering information on fish and fish habitat is also part of the site assessment process. Most of the information required for this step of the process can be gathered in databases such as the Department of Fisheries and Oceans Aquatic Species at Risk Mapping Tool and Alberta's Fish and Wildlife Mapping Tool. Databases such as these identify if particular fish species are likely to be present in a given area, and if there are any species at risk to be aware of. Remember, the absence of data does not equal the absence of fish, and if the required fish information cannot be found, fish sampling in the area may be required. During the field portion of the site assessment, there are key types of information that need to be gathered to ensure that the crossing design can achieve all of the goals of a watercourse crossing. Habitat assessments must be completed during open water seasons. Avoid conducting habitat assessments in the winter and during high-flow events. Watercourse crossing structures need to provide fish passage, minimize erosion and prevent sedimentation, maintain water flow and match natural stream velocities, be resilient to climatic changes, and maintain healthy aquatic habitats. The information that should be collected to inform the design of the watercourse crossing includes channel characteristics, channel gradient, water velocity, channel width, water depth, substrate type and size, evidence of erosion and bank instability, bankful discharge, bankful depth, geometry of the watercourse cross-section. A field survey of the potential watercourse crossing site includes more than just the immediate area where the watercourse crossing structure is intended to be placed. The field survey should also include upstream and downstream areas. A good standard of practice is to ensure the minimum survey length is 20 to 30 times the bankful width of the watercourse. The bankful width is the horizontal distance between annual high water marks. If there are other features in a segment of the watercourse, such as an existing watercourse crossing, the survey length should be increased. This survey may determine the effects that a watercourse crossing may have on fish habitat and identifies key habitat features, such as places where fish spawn, overwinter, or rear their young. In the case of a culvert installation or replacement, the survey area should include several reference sections to help determine the natural channel characteristics. The reference sections should be selected using the following criteria. The reference section is at least as long as the planned culvert structure. The reference section is as straight as possible. The slope, channel shape, and water flow is similar to those of the planned crossing location. Once an appropriate reference section has been located, the following measurements can be collected to ensure the watercourse crossing design and installation can replicate the channel and habitat characteristics of the watercourse. Channel width at its bankful discharge, which is the maximum amount of discharge a channel can accommodate without overflowing. Bankful discharge. Bankful depth. Channel width. Depth of water. Geometry of the watercourse cross-section. It's important to take measurements far enough away, ideally upstream, from other disturbances such as existing road crossings or tributaries, so that the measurements are not influenced by these other features. Collecting a good quantity and quality of site information prior to design and installing watercourse crossings is key to their success. It's important that desktop and field survey methods collect the right information to ensure that the design and location of the watercourse crossing structure can achieve all of its intended goals.